So what's up guys, welcome to Coding Pilot. In the edition of this video, I want to be creating machine learning models for our diabetes data set. Okay, how cool is that? We're going to be diving into the world of modeling. Okay, so in our previous video, we did exploratory data analysis, okay, where we covered a lot of concepts, okay. We covered univariate analysis, multivariate analysis, we compared each of the columns, okay. So we compare the blood glucose level and diabetes column so that the higher your blood glucose level, the higher the chances of you getting diabetes. And also we also compared the hemoglobin level and the diabetes level. Okay, we also make observation on that. So basically in this video, today's edition of this video, we're going to be creating machine learning models. Okay, and before I told you guys that the machine learning model we're going to be using is going to be logistic regression. Okay, logistic regression, which is a very good model for this case scenario. Okay, so before we head into modeling, we're going to be splitting our data set into dependent and independent variable. Okay, into target variable and the variable which we are going to be predicting on. So to do that, I'm going to say my x equal to my df. Okay, I'm just going to drop my diabetes column, diabetes, which is as one. Then my y should just be my diabetes column. Okay, diabetes. Okay, let me just check. Okay, I want this. Then let me check my x. Here you can see my x, which we'll be using to train our data set, which is my independent variable, and also my y. My y will be a series that contains just one column, diabetes. Okay. So next step now, I'm going to be splitting my data set into train and test. Okay, we don't really want to use all our data set for training. That is just the basic principle of machine learning. Save some data set for training and the other for testing. Okay, so the rule of thumb which we normally use is that we use 80% for training and 20% for testing. Okay, let me say okay, x train, x test, train, y test. Okay, y test. Okay, which should be okay. I forgot to import a model. Model which we are going to use to split our data set is going to be the train test split, which is a model from sklearn model selection. From sklearn. Okay, selection. Want to import train test split. Okay, then we'll just say train test split. Okay, my x, my y, then my train size be 80%. Total data set, then my test size will be 20%. Then just give a random state so we don't end up with different distribution of data set anytime we run this block of code. Okay, so use 42. Let me just check my string shape and string, sorry, test shape on this. Here you can see 80,000 row of our data set will be for training, while 20,000 row of our data set will be for testing. Okay, so same also go with the target variable, which is my y. Okay, so now let us head on to the part which we all have been waiting for, which is the process of modeling. Okay, this is one of the my best parts of machine learning. Okay, unlike the process of cleaning your data, which is very, very tedious and stressful. Okay, we all know the life cycle of machine learning, where you spend more than 80% of your time with pre-processing your data, cleaning your data, making sure that it's fit for modeling, and just 20% of your time in just about 30% or so in just building your model. Okay, so this is phase we are now, modeling of our data sets. Okay, so we're going to import logistic regression from sklearn. Okay, from sklearn dot linear model. We're going to import logistic regression. Okay, me import it. What's going on? Okay, from here I've imported it. Okay, so we have modeling already as a markdown. Let me just convert this to logistic regression. Okay, so it's more readable. Logistic regression. Okay, so to do what we're doing is now is to instantialize our model. Well, this model should be my logistic regression. Okay, and fit our model. Model.fit s train and y train. Okay, we train our model with our training data set. Okay, it's going to take some time to fit because of the size of the model. It has already been fitted. Then the next step now is to make predictions. Okay, next step of everything now is to make prediction, see the performance of our model. So to make prediction, we're just going to simply call, let's store it in the variable widespread. Okay, should be my model dot to predict x test. We want to make predictions on all the features of my x test. Okay, so it can give me a predicted variable which is going to be my y test. Okay, when we want this now, then let me see my y spread. Okay, okay, so here is our predictions. This is not quite readable now. Let me actually create a data frame for this. Create it as data frame. So we can actually visualize both my actual and my predicted variable. Okay, so I'm just going to call for this actual, and this is going to be widespread, widespread. Just visualize 15 predictions, and okay, my prediction. Okay, prediction. Okay, then this should be okay. Let me visualize this now. Okay, here we have it. Our first 15 prediction. Okay, from our latest observation in data set we have here, you can see that our model's prediction virtually got all of them correctly. Okay, you can see I didn't make any mistake. Okay, let me actually increase the size of the observation. Let me see to 30. So let's see how model is performing. Okay, here we see how it. Wow, our model is really performing well on this data set. Okay, I mean it just literally got everything. Okay, so you know what to do now. It's actually a very ineffective way of actually evaluating your model. Okay, I mean because we have over 90 sorry, we have over 10,000 test data set. Okay, I mean we have 20,000 data set, and you can actually get an actual overview of how our model is performing on each of them. So that's where another model come into play from SQL. We just import sklearn dot metrics. Yeah, I guess it's the model which is found from sklearn metric. We want to import the accuracy score. Okay, accuracy score. Then I'm going to say um accuracy score. Then we replace our y test, which is our actual, and our y squared. Okay, let me run this now. This score is not defined. Okay, there's a typo in my spelling. Accuracy. Let me run this again. Okay, here we can see our accuracy score is 94%. Wow, which is actually performing above your normal machine learning algorithm, which has been building for quite some time now. Okay, I mean it's really performing well. So hands to ourselves, we really tried in this machine learning project. It's, our model is really performing well. Okay, it's really performing well. It beat my expectations, 94% accuracy. Okay, so to apply this our machine learning model, we should just build to other future use. You can actually just create a data set that contains same size of features. Here which I mean was, I guess, where it was 16 columns. Just say yeah. So it was 16, not 16 column though. Yeah, it was 16 column. Just fill in the values, your age, hypertension, heart disease, BMI, hemoglobin level, blood glucose level, diabetes, pregnancy, smoking history, and other features. Okay, just create a data set like this, or you can actually create an application where the user actually enters all of these features, and your model will predict if the user has diabetes or not. But I mean, this result also have to be reviewed by a doctor, okay, by a professional doctor to actually get the full description of the patient's health. Okay, so that will be all for this video. I mean, we have gone a lot of steps. We have done a lot of things in this video. Okay, so guys, please don't forget to subscribe to this channel. Support me by subscribing to this channel for more data science and machine learning videos and projects like this. Okay, guys, see you in the next video.